In Unit 3, we are going to see about the input-output interfacing. In this unit, the following topics are present: input-output interfacing, parallel communication interface, keyboard or display controller, timer, digital to analog converter and analog to digital interface, serial communication interface, interrupt controller, DMA controller, and programming and applications case studies, which include traffic light control, LED display, LCD display, keyboard display interface, and alarm controller. The very first topic is input-output interfacing. Input-output interfacing is needed to transfer the data between external circuitry to the microprocessor and microprocessor to the external circuitry. Input devices give the information to the microprocessor and output devices are used to display the information from the microprocessor. The input or output data transfer is controlled by read bar or write bar and IO, that is input output slash memory bar signals. The input output devices can be interfaced to the 8086 microprocessor in two different methods, namely memory mapped input output and input output mapped input output, which roughly used as memory mapped IO, IO mapped IO. Memory mapped IO is a way to exchange the data and some of the instructions between the microprocessor and the peripheral devices which is attached to it, whereas memory mapped input output is one where the processor and the input output devices share the same memory location, that is the same memory. The processor and input output devices are mapped using the memory address, whereas IO mapped IO, it's a general purpose port which is used by any microprocessor or even microcontroller to handle the peripherals which are connected to it. IO mapped IO has a separate address space from the memory. A separate signal is used for addressing an input output device, and in the case of memory mapped IOs, they share the memory space with external memory. And let's see the differences between the memory mapped IO and IO mapped IO. Whereas in the memory mapped IO, the input output is treated as a memory, but in the case of IO mapped IO, input output is treated as a input output only. Memory mapped IO is the 16-bit addressing, whereas IO mapped IO is a 8-bit addressing. Memory mapped IO, it has more decoder hardware, whereas IO mapped IO has less decoder hardware, and it can address up to 2 power 16, that is 64K locations, but IO mapped IO can address only about 2 power 8, that is 256 locations, and less memory is available in the case of memory mapped IO. In IO mapped IO, whole memory address space is available, and in the memory mapped IO, memory instructions are used, whereas in the IO mapped IO, special instructions are used like in or out. In memory mapped IO, memory control signals are used, whereas IO mapped IO, special control signals are used. Arithmetic and logic operations can be performed on the data in the memory mapped IO, but arithmetic and logic operations cannot be performed on data in the IO mapped IO. Data transfer between register and IO is possible in memory mapped IO, whereas data transfer between accumulator and input output is possible in IO mapped IO. And how the data are transferred in this IO interfacing means by the way of two methods, namely synchronous and asynchronous. Synchronous data transfer usually occur when peripherals are located within the same computer or the microprocessor. Close proximity, it allows the all state bits change at the same time on a common clock. So microprocessor system uses the same clock frequency. It can also be termed as synchronous data transfer, whereas in the asynchronous data transfer, it do not require that all the source and the destination use the same system clock, which means a microprocessor and the interfacing devices may use different clock frequency. And how the memory and I/O interfacing is being done. This diagram symbolically represents where you can see a microprocessor is available, and at the bottom we can see some of the memory devices also available. Memory devices means read-only memory and random access memory. So here dynamic RAM and read-only memory are connected. Similarly, I/O devices like keyboard or printer are also connected to the microprocessor. We can see how these memory devices and I/O devices are connected to the microprocessor. With the help of data bus and address bus, these memory devices or I/O devices are connected to the microprocessor. These devices are connected to the microprocessor by using some commands. For example, input output read cycle, input output write cycle, memory read cycle, memory write cycle. Thank you.